All right. Here we have a moment problem, and we are given a diagram having forces R1, R2, 40 Newton, 48 Newton, 38 Newton. The question asks us to calculate the reactions, that is R1 and R2 on pivot A and B. To be able to solve questions like this, we need to have the understanding of the principles of moment. Okay? They are very important. One of them is when a body is at equilibrium, the total upward forces, all right, total upward forces must be equal to downward forces. I repeat, it says when a body is at equilibrium, one of the principles of moment states that when a body is at equilibrium, the total upward forces must be equal to the total downward forces. So what are the upward forces? If you look at the direction, this is an upward force, this is an upward force. Okay, so that is going to be R1 plus R2 is equals to the total downward forces. What are the downward forces? We have 40 Newton, 48 Newton, and 32 Newton. If you look at the arrows, they are facing downward, so they are downward forces. Okay, that will be 40 plus 48 plus 32, and that's supposed to give if I add them together, I will have 40 plus 48 plus 32, 120 newtons. So that means R1 plus R2 is equals to 120 newtons. Okay? Now, the other principle of moment states that when a body is at equilibrium, the sum of the clockwise moments must be equal to the sum of the anti-clockwise moments. Okay? Clockwise moments, let's write that. Clockwise moments is equal to anti-clockwise moment. So that is another principle of moment. All right. So, but how do we determine if a force is clockwise or anti-clockwise? The first thing is we have to take moment from a certain point, okay? Now, I can take moment here. I can take moment directly at pivot A. I can take moment at this point. I can take moment at this point and moment at this point. It doesn't matter. The answer will be the same, okay? But for simplicity, I would either take moments from pivot A and from pivot or from pivot B. And after doing that, then I'll be able to identify if a force is going clockwise or anti-clockwise. So that is if a force is acting clockwise or anti-clockwise. Now, to be able to do that, first, let me try and see how will it look like if I should assume that I have only pivot A, for instance. So this is, let's try to draw it roughly. All right. we're going to have a force here, going to have a force here, we have an upward force here, we have a force here. We have 40 newtons, 48 newtons, 32 newtons. This is R2, this is R1. Okay, let me go back to the main diagram and see what is missing. Let's try to indicate them. 0.4 meters, I have 0.5 meters, I have 0.3 meters, I have 0.2 meters. Okay, so this is how it is. I am assuming that I'm only doing my consideration from a single point. Okay, so if you look at it, I have just knocked out pivot B. I am only indicating pivot A because that will be my reference. Whatever I am to do, I am taking reference from pivot A. Okay, so let me guide you and let's try to identify the clockwise moments and the anti-clockwise moments. All right, so to do that, if a force is acting downward, it will continue to act downward towards the pivot concerned. So this is a downward force, so this 32 Newton also is going towards the pivot. So we have a 14 Newton force here. So the only way for it to continue to act downward towards the pivot concern is when we draw it this way. Okay, so I have R2. The only way it can come to this, it can act towards the pivot of reference, because it's an upward force, it will continue to act upwards. All right, so we're going to have it this way. All right, so how about R1? If you are taking moment at any point, the force at that point, the moment is going to be zero, okay, because it is not defined by any distance. Because the distance is zero, the moment there will be zero, if at all we are considering moment at any point. All right, so let's label what is the clockwise and the anti-clockwise moment. All right, if I have something that looks like this, is clockwise. If I have something that looks like this, is anti-clockwise. All right, so therefore this is clockwise. This is also clockwise. All right, this is anti-clockwise. This is also anti-clockwise. Okay, being able to identify whether a force is clockwise or anti-clockwise is very important. Otherwise, you will mix up everything. Okay, so I am now going to proceed. So what are the clockwise moments? You know that moment is the product of force and distance. So by considering the 48 Newton force, what should I multiply it with? From the reference point is the distance that it travels. That is, it is acting on, that's the right statement. The distance at which the force is acting on is only 0.5 meters. Okay, so that will be 48 times 0.5. Okay, that's a clockwise. What is the other clockwise moment? Is 32 Newton. So, but what is the total distance from which the force is acting? All right, that is 0 0.5, 0 0.3, 0 0.2. If you look at it, because the reference point is A, okay, as the pivot. So that will be 0 0.5 plus 0 0.3 plus 0 0.2. We are done with the clockwise moment. So we said this must be equal to the anti-clockwise moments. So what are the anti-clockwise moments? We have R2, okay, R2 multiplied by the distance from which the force is acting. All right, so if this is R2 and this is the reference point, what do we have? We have 0 0.5 and 0 0.3. Okay, so that will be, let's say, zero 0.5 plus 0 0.3. Okay, and what is the other anti-clockwise moment? Is the 40 Newton. Okay, the other anti-clockwise moment is the 40 Newton. That should be multiplied by what? We look at it, the distance from which the force is acting is only 0 0.4 meters here. All right, 0 0.4 meters. So then we can do the calculation. 48 times 0 0.5, that is 24, plus, if you multiply this, that is going to be 32 multiplied by 0 0.5 in bracket plus 0 0.3 plus 0 0.2 bracket close. We're going to have 32 is equals to 0 0.5 plus 0 0.3 is 0 0.8. If you multiply by R2, you're going to have 0 0.8 R2 plus, so what is 40 multiplied by 0 0.4? That is going to give you 16. So what is 24 plus 32? That is 56 is equals to 0 0.8 R2 plus 16. Okay, so what do? We collect like terms. We'll have 56 minus 16 is equals to 0 0.8 R2. 56 minus 16 is 40 is equals to 0 0.8 R2. So if you divide both sides by 0 0.8, we're going to have R2 is 40 divided by 0 0.8. So what is that? 40 divided by 0 0.8. R2 is 50 newtons. Okay, so on the diagram, R2 is 50 newtons. But we already know that from the first principle that we have stated, R1 plus R2 is equals to 120 newtons. So what is R2 is 15. So R1 plus, if I should substitute that, that will be 50 is equals to 120 newtons. So R1 is equals to 120 minus 50. R1 is equals to 70 newtons. Okay, so which means the value of R1 is 70 newtons and R2 is 50 newtons. All right, this is how to solve moments problems. Okay, two important principles that we need to remember. The first principle is when a body is at equilibrium, the total upward forces must be equal to the total downward forces. The second principle is when a body is at equilibrium, the total sum of the clockwise moments must be equal to the total sum of the anti-clockwise moment, taking moment from the same point. Okay, that is important. So in the next video, I will try to take moments from pivot B instead of pivot A using the same example, and I guarantee you that we're going to have the same answers again. So, like I told you, it's simple. Moments can be taken from any point, okay? It can be taken from this point, from pivot A, from this point, from pivot B, from this point, and you'll have the same answer. The only thing is, should you take moments outside of the pivots, usually you're going to have a simultaneous equation that you can solve to get it. So the answers will be the same, basically. All right, thank you very much.